Hello, today we are going to learn improper integrals with infinite discontinuity. This is the second type of improper integrals. In the previous class, we learned improper integrals with infinite intervals. So today we are moving to the second type. Let's discuss the definition. The integral integration from a to b f of x dx is improper with infinite discontinuity if fx has an infinite discontinuity at C, where C is from A to B. That means there's a point in this interval where the function f of x is discontinuous. Okay, where the function f of x is discontinuous. All right, let's move to an example so you can understand this very well. Example number 1. Let's say you are given integration from 0 to 3, 1 over x minus 1 dx. Here the function is 1 over x minus 1. You can see this function is discontinuous at x equals 1. Is this okay? This function is discontinuous at x equals 1. Because it is discontinuous at x equals 1, you won't be able to integrate from 0 to 3. It is impossible to integrate from 0 to 3 because it has this discontinuity at 1, which is in between 0 and 3. Okay, so let me give the method in this section. This method has 3 parts. The first part of the method, if f is continuous on A to B, at A you have closed interval, at B you have open intervals, and discontinuous at give me a second. At B, then integration from A to B f of x dx equals limit t goes to b infinity, t goes to b from the negative side, and then integration from a to t f of x dx. Okay, let me explain this case a little bit. What I'm saying is this function is discontinuous at a. So this is the interval you have. Let's say this is a. So this is a, that is b. So it is discontinuous at b. Okay, so you can color b if you just mark. See, if you just mark points, this point can be colored, that point can be colored, okay, because that is discontinuous at b. Because of that reason, you won't be able to integrate that at b. Because of that, what we do, we just assume there's something like t here. We assume there's a variable t here, and then we integrate the function from a to t. Alright, we integrate the function from a to t, which is right here. Thereafter, we say t goes to b from the negative side. This, how do you read this? This is read as t goes to b from the negative side. Alright, t goes to b from the negative side. What is the negative side? Negative side is this side. This is the negative side, that is the positive side. Always right hand side is the positive side, left hand side is the negative side. This says t goes to b from the negative side. That means this is what you are doing. You just send this t to b from this direction. Okay, so this is the negative direction. You are approaching to b from the negative direction. If you are approaching to b from the positive direction, that is that direction. Alright, so keep that in mind. So that's part A, and then move to part B. Part B, if f is continuous on AB, here A excluded, I have parenthesis at A and square bracket at B, and discontinuous at A, then integration from A to B f of x dx equals limit. Now you write t goes to A from the positive side, integration from t to b f of x dx. Okay, let's understand this scenario. Now you have A like this and B like this. This is discontinuous at A but continuous at B. Alright. Now what you are doing is you are just taking t somewhere here, and then you are integrating the function from this from this point to that point, okay, which is given by that. It is from t to b, and then I say t goes to a from the positive side. T goes to a from the positive side. Let me copy this. Copy, paste. This is positive. That is the meaning of that. The positive side is actually this side. So you are reaching to t from the positive side. Sorry, I'm sorry. What I'm saying is, you are reaching to a from the positive side. Okay, you are reaching to a from the positive. Let me rewrite this. You are reaching to a from the positive side. Here also, let me just edit that a little bit. You are reaching to all right. So that is the second case, case B, and then move to case C. If f is continuous, on AB and is discontinuous at both A and B. Now it's discontinuous at two places. Then you write integration from A to B f of x dx. Alright, now it's discontinuous at A and B both. So you use case A and case B for case C. Alright, case A is for discontinuous at B, case B for discontinuousness at A. Now case C is discontinuous at both A and B, so you use A and B both for case C. This equals limit t goes to A from the positive side integration from t to c f of x dx plus limit t goes to B from the negative side c to t f of x dx. Alright, so that is case number C. Alright, let's move to example so you can understand this very well. The first example you have is right here. I gave you the example early. Let me copy this example. Alright, so that is example number 3. So example number 1, which is integration from 0 to 3, 1 over x minus 1 dx. Now this is this is discontinuous at x equals 1. All right, so what you do now? Now you just split this integral to two integrals. All right, let me explain how do you split this. You split this into two integrals, that is integration from 0 to 3 1 over x minus 1 dx equals integration from 0 to 1 1 over x minus 1 dx plus 1 to 3 1 over x minus 1 dx. All right, so you have two integrals. Now you started with one, now you have two integrals. For this you use one of the law that you use in integration. All right, so you can just split any integral into two parts like this, and then you're going to use the method that I gave you earlier. All right, so this is discontinuous as at x equals 1, so it is discontinuous at there, discontinuous at there. Okay, for this part you could use part B. I'm sorry, for that you could use part A, and then for this you could use part, this is part A, for this you could use part B. All right, all right, so go forward. Now you write here, now here you're going to introduce the limit t goes to 1. Now you have to determine whether it's positive side or negative side. I will explain it somewhere here, maybe using the green color. Here you have 0, here you have 1, that's the number line. It is discontinuous at 1, so you are reaching to 1 from the negative side. Okay, so then this should be negative. All right, then you write integration from 0 to t x minus 1 dx plus limit. Now t goes to 1, you have to determine which side here. Let me determine it later. Here I put t to 3 1 over x minus 1 dx. And so this is 1, that is 3. So it is discontinuous at 1. Here this is discontinuous at 1, so you are reaching to 1 from the positive side. Okay, so because of that reason you put positive here. I'm sorry, not that. You put positive right here. You are reaching to 1 from the positive direction. All right, so we wrote the formulation and then we have to integrate. This equals, you could keep this limit part separately. First thing is to integrate this and integrate that while keeping the limit part separately. So the integration of that one should be ln x minus 1. The limits are 0 to t, and then for this one you write limit t goes to 1 from the positive side. The integration of that one is ln x minus 1 from t to 3. Okay, now for this one you just apply the upper limit and then the lower limit. Limit t goes to 1 from the positive side, then this is ln t minus 1 minus ln 1, and then limit t goes to 1 plus ln 3 minus 1, which is 2, minus ln t minus 1. Alright, you know ln 1 is 0. And then you have to find these quantities. This equals limit t goes to 1 from the negative side, ln t minus 1. Alright, then plus you have ln 2. You can take the limit part out from the ln 2 because that's independent of limit. And then for the rest you would write minus limit t goes to 1 from the positive side, ln t minus 1. Alright. Now you have to determine this and that. You have to determine these two limits. Okay, before that you better draw ln t minus 1 absolute function. Alright, so you better draw ln absolute of t minus 1. Before drawing ln t minus 1, let's draw ln t. Okay, you know how to draw ln t, which is easy, that you have drawn in calc 1. This is the plot of ln t. So it goes like, I'm sorry, it's my bad. The ln t function should go like this. This is 1. And here also it has the same shape. Alright, so this is ln absolute t. Now you have to draw, by learning from this plot, you have to draw ln t minus 1. In ln absolute t minus 1, what will happen is the same plot will be shifted 1 unit rightward. You have to shift this plot 1 unit rightward. Okay, once you shift this 1 unit rightward, so this is the place where you have the asymptote. You know, this is 1, and let us this should be minus 1, and this should be 0, and this is 0, this is 2. Okay, then there should be an asymptote at 1. Let me put 1 here. Okay, so the curve should look like this. That is ln t minus 1. Okay, now what I'm going to do, I'm going to use these two curves to determine the green parts. Alright, so let's work on this first. Work on that first. That says you have to find out ln t minus 1 absolute of t minus 1 when t goes to 1 from the negative direction. From the negative direction means this direction. This is the negative, so you go to 1 in that direction. When you go to 1 in that direction, the function value goes to negative infinity. You see, it goes to all the way down. It goes to negative infinity. That is this part. In this part, it says you have to go to 1 from the positive side. That means you are reaching from the positive side, like that. Okay, when you are reaching to 1 from the positive side, this curve goes to again negative infinity. Okay, so this part is negative infinity, that part is negative infinity. All right, so let me take these things out. Okay, let me write something here. We see that limit t goes to 1 from the negative direction ln t minus 1 absolute goes to negative infinity, and not only that, the other integral is also going to infinity. Sorry, limit t goes to 1 from the positive side ln t minus 1 absolute also going to negative infinity. Now let's consider that as equation number 1. By 1 we write the integral should be which is integration 1 over x minus 1 integration 1 over x minus 1 dx from 0 to 3 equals, this is negative infinity, that is negative infinity, so you write negative infinity then plus ln to negative infinity. All right, so you have two negative infinities and then ln 2. The answer is negative infinity. For negative infinity you could say it does not exist. So the result is integration from 0 to 3. That integral is negative infinity. Thus, since integral is negative infinity, we say integration from 0 to 3 1 over x minus 1 dx is divergent. Alright, so that is the answer. And now we move to the next example. Example number 4. Sorry, example number 2. We discussed one example, so this is example number 2. We integrate from 0 to 1 ln x dx. All right. So the thing is, ln x is not defined at 0. Your function f of x is ln x is not continuous at, or is not continuous, or it is not defined, or not continuous means not defined in this case. Okay, it is not defined at x equals 0. Okay, so let me repress this. This has infinite discontinuity at x equals 0. Alright, now you have to avoid that point. So you write this integral as 0 to 1 ln x dx as integration from t to 1 ln x dx, and here you write limit t goes to 0 from the positive side. Okay, let me explain that, how it comes. So here you have 1, here you have 0. It is defined at 1, it is not defined at 0. So you are reaching to 0 from the positive direction. So that is the right hand side is the positive direction. So you are reaching to 0 from the positive direction. Alright. So now let me take this as equation number 1. That's equation number 1. In equation number 1, first we just compute this integral and then we work on the limit. First compute that. Alright, so that is here. Let me take that as A. A equals integration t to 1 ln x. First I integrate that and then I just use equation number 1 to impose limit. Okay, so just integrate that. You have learned how to integrate this in integration by parts. So I'm using that knowledge. Since you have done integration by parts, this is easy. This is for that you have to find two functions, u and v. But of course, I see one function here. So where's the other function? For the other function, you can assume 1. So the two functions are integration t to 1 ln x and then the next function to be 1 dx. Okay, take this as u, take that as v prime. All right, so u is, u is ln x, v prime is 1. Since v prime is 1, v is integration of 1, which is x. Now you know v and u both. This is v, that is u. Okay, if you use the integration by parts, the formula should be integration from t to 1. Let me write like this. So I'm using integration by part formula. It is uv. You have to apply the lower limit and then the upper limit minus u prime times v dx. Here the lower limit and the upper limit. Okay, so uv should be ln x times x. The limits are from t to 1 and minus integration from t to 1. U prime should be 1 over x. That is u prime. So the u prime is 1 over x. And v is x dx. So you can cancel this with that. And then here you apply the upper limit 1 ln 1 minus t ln t. And there you have integration from t to 1 dx. Okay, you know ln 1 is 0. So this will be minus t ln t minus integration of this part is just x, which is just x, and then limits are from t to 1, and then you write this as minus t ln t minus 1 minus t. Right, so this equals minus t ln t minus 1 plus t. So this is the solution for part A. green color part A. Okay, now I'm going to plug that part A into this formula. Alright, so go forward. Give me a second. Alright, now go by 1. Equation 1, that means this equation here 1. By that equation you write integration 0 to 1 ln x dx equals limit t goes to 0 from the let me see from which direction, from the positive direction, and then you write the entire solution for the integral, which is minus t ln t minus 1 plus t. Alright, then you apply the limit t goes to 0 from the positive direction. Here t ln t, let me put that minus here, and then you have minus 1, and then you have plus limit t goes to 0 from the positive direction t. So this part will be 0, that part is 0, and you have to find the solution for this part. What is the value of limit t goes to 0 from the positive direction of t times ln t? Alright, so you have to find this thing. This is a little hard problem. If you just plug t equals 0, you'll get 0 times 0, which is undefined here. Because of that reason, you could use L'Hopital's rule. You have learned L'Hopital's rule in Calc 1. Let's use L'Hopital's rule. So let's take this part as part B. This is a little hard problem. Now you have part B. Now I'm going to work on part B separately. Part B equals limit, let's say negative, with t goes to 0 from the positive direction. Then I write ln t as t times ln t as ln t over 1 over t. Alright, so I'm just writing like that because the Hopital's rule works like that. Since you have learned Hopital's rule in Calc 1, I believe this is easy. Alright, first of all, you apply the limits. Once you apply the limit, what you get is, in the numerator you get 0, in the denominator you get infinity, which is not defined. This does not exist. Okay, now the Hopital's rule says just get the derivative of the numerator and the denominator. Right? By Hopital's rule, you could say limit t goes to 0 from the positive direction, you get the derivative of the numerator, which is ln t, and then you get the derivative of the denominator, which is minus 1 over t square. So this is Hopital's rule. Let me write that. By Hopital's rule. Okay, by Hopital's rule. Okay, now just get the limit. First of all, you can cancel some terms. You write this to be limit t goes to 0 from the positive side. Once you cancel the limit, what you have is negative just t, because you can cancel this 1t with 1t over there, and then you can get that t into the numerator. So what you have is negative t, and now you can apply the limit. Once you apply the limit here, what you get is just 0. So b is 0. Okay, b is 0. Now b is 0. Now you could write, let me write this as equation number 2. By 2 you write equation 2 you write integration from 0 to 1 ln x dx equals, this equals, b is already 0, 0 minus 1 plus 0, okay, which is minus 1. Okay, the integral is minus 1, that means it converges. That means integration from 0 to 1 ln x dx is convergent. Alright, so we discussed very good at 2 examples. So this is the second example. Second example is little harder because it went through several steps. Let me go through the second example. So this is the second example where you computed the integration of that. This function is not defined at x equals 0. Alright, then you just integrated this green part separately right here. Alright, the integration of that one is right here, and then you applied this limit part. Okay, right here. Thereafter, you got this function, which is little hard to compute. You have to compute the limit of that. Computing limit of that is little hard. Because of that reason, you use Hospital's rule, which makes the process easy. So you found this integral to be minus 1, then you said it is convergent. Alright, I gave you the definition of convergent and divergent in the previous class, so you can remember that. Okay, so that's all for today. Thank you very much.